Okay, so the next step with this is actually to get the rest of the data frame and put it all together. So here we go. What we're going to do now is select, you could say select DF census columns that are numeric. Now, when you're building a data frame, there can be different types of numerics. It's kind of easy to actually instead of include to exclude object. So I call it now the cold data frame. Okay, is just what? Well, it's DF census, and now I want to do the dot select only certain D types. Okay, and what you can do those you can do by excluding. See, look at this. You can exclude, and then within that you want to put in the list object. Okay, so that should exclude type object. And just to show you now, well, what would it look like? Or what would it look like? Did it do it right? Right, that's another thing you could look at. Let's check it. See how this is just the numerical columns now, right? Okay, so now we just have to put them together. And this does require a couple things, okay? But what I would encourage you all to do is to actually chunk the essential code in together to do it. Because some of this I'm just showing you like what it looks like and things like that. Okay, so how do we do it? Okay, we're gonna do the following. So from SciPy, says we're scientific Python dot sparse, we're dealing in the world of sparse matrices. You can import a CSR matrix. And again, you don't have to go through all these steps if you're going to one-hot encode the whole matrix. Okay, but you don't want to do that when it's actually split up. So it's kind of a unique, challenging case, all right? And then we're also going to import hstack. Okay, so what do? We're going to do cold equals CSR underscore matrix. So this is a kind of a sparse matrix. And we put the cold DF in there, okay? And then we just want to stack it. And so like, I don't know if we want to call this, I need a new name for it. The final matrix. You know, they're making a new Matrix movie. It's funny how, you know, with recordings, like this is 2021, so it's around this time. And you can do an H stack and you just combine them. Okay, and what are you combining? This is done in tuples, hot, comma, cold. Technically, you want to do cold, hot because the last one, you know, I think is that the column the target column. Okay, and now, you know what? We really should have done a split out X and Y like first. So we can go back and look at that. But that should do it. It gives us a final matrix. And note that when you look at it, this is now a sparse matrix. Okay, so if I type it in, it should be sparse. Let's check. Yeah. See, it's telling you it's a sparse matrix. See, it tells us the total number of elements, right? So the total number of elements in the sparse matrix is 394,963. And if you recall from before, like let's just compare it directly. When we do DF census, DF census dummies. This is the non-sparse one. And we do the 0 times the 1, dot shape. So this is number of rows times number of columns. Okay. Sorry about that. And so we're going to compare now. This gives us, see, 3 million columns versus 394. So it's a factor of 10 better. This makes a huge difference. Okay. And you know, depending on like the size of your data is going to depend on whether you're going to actually use that or not. because I would use pd-get dummies unless the models are taking much too long. Then, and it's also, look, this is only useful when you're using pd-get dummies, like when you have categorical columns. This isn't going to help you if you have like a bunch of numerical columns, okay? So one-hot encoding is specifically an alternative to pd-get dummies to create a sparse matrix. And what we've just done is we've looked at a very intricate way of doing it, because we had both numerical and categorical columns and we needed to fix it. Now, I'm pretty sure when we do it at the very end, to check this, see the final matrix, I think I've got to go back. I should have done the X and the Y thing first, because this, let me actually show you how I would do it. Okay, because when you have, see, the final matrix, let me go ahead and just put it in here. It's, oh yeah, it's already the sparse it's telling us, but if I print it out and I look at it, right? Well, let's check, like, about, can I just get the last, see, because it's stored differently. And you see how it includes, at the end, it's including the, look, these are the patients that have heart diseases. Okay, it looks like, I'm pausing because that can't be all of them. So yeah, it can end up in a different order. So we actually need to go back and specify the order. But note what's kind of cool here is that it's including now everything, all numerical columns. Okay, so that's basically, the tool. So let me show you now what I would do to kind of just, oh yeah, let me like separate out at the beginning. So because Y, right? Y is not going to change. When I say X and Y, like Y is just going to be a bunch of numerical values. That's what we're trying to predict. Whereas like X, the input, is what we want to be the sparse matrix. So how would you change that? And you could think about that yourself. Well, I think we want to start it with the get dummies, because when we have pd-get dummies, okay, it's clear that that what we're trying to predict is the last column, right? Whether something's greater than or equal to 50K. So what I can do is I can set the predictor column in advance if I go in here. That's at the end. Well, I could still actually do it. Well, you could do it there, but I want to go back and do it up at the top. Okay, I want to do it when I do the pd-get dummies. There are a lot of ways that you could state the Y column. Okay, this is just one of them. So what we're going to do here is set Y column in advance. Okay, and that's just going to be, so Y equals, we can do df census dummies, and then we're going to be using .iloc all rows, but just the last column. Okay, so that's going to store Y properly. And now what we're going to do in the one-hot encoder is we're going to do it actually on X, okay, not on Y. And so what we can do for that is note that when we're doing the one-hot encoder and we're looking at like the columns of df census, okay, we can like, instead of rewriting like X equals, I mean, we could change it. Like what I'm going to do instead, though, to be a little quicker here, is I'm going to define df census. And so this is going to be like our X. You know what? Let's just do it right. Let's do changes. So X would equal df census. Well, it's all columns except for the last one, right? That's how we usually do it. So it's .iloc. And it's, again, all rows, all columns except for the last. And now that I'm doing it, it seems like, why don't I just put it with the Y? Okay. So I think these are always kind of fun when it's like, it's a little all over the place. Shows you different ways that people can do anything. Also set X columns in advance, you could say. And then when we set it up like this, okay, now what I've got to do is see, I can type x.info. Everywhere I have df census, I really want to put an x in there. And you can see it excludes the predictor columns, okay? So we got to just change everywhere there's a df census. I'm going to change it to an x. A little tedious, but this is how it goes. And I want you to be able to appreciate why we're doing this, because it has to do with the importance of, like in machine learning, it's like input output. And so whereas I can do it on the whole, say, see, hot is already defined properly. On the whole data frame, really you want to do it just on the input columns, not on the output columns. Okay, so it's possible I miss a df census. This looks okay. Now to be on the safe side, what I'm going to do is runtime, restart, and run all. And then the other thing is that what we've called final matrix, it's really going to be the input of our machine learning model. It's going to be our x. Okay, so in effect, we could redefine it. We've got y set. I want to redefine that x equals the final matrix. Okay, so when you do runtime, restart, and run all, it goes in order, top to bottom. Click yes. And, hopefully there are no errors, and then we should be good to go to now build. Oh yeah, it didn't work. See, it's hard to catch them all when you make changes. So go to runtime, restart, and run all again. But now we should be good to build a random forest using one-hot encoding. And again, I do want to emphasize, it's usually not this involved, okay? This is giving you an insider's view of one-hot encoding, and it's commonly used for text data where the whole thing needs to be one-hot encoded. All right.